Welcome to my YouTube channel. Today, let's discuss about high-level design or system design interview round. So, in this round, interviewer is testing how you will be able to design a scalable system or a system which is resilient. So, so you might have seen different questions in interview experiences where interviewers ask people to design over Instagram, Facebook, then many similar systems. So what is the intention and what are they looking for? It depends on the role that you are applying for. Maybe for mid-level roles, they are looking at how you will be able to design the system with a little bit of hand-holding from the interviewer. For more senior roles, they would be looking at the how the guy is able to design end-to-end system with minimum or no hand-holding at all. So whenever you are designing a system, we need to think how will the system change and how will the system change whenever customer base is increasing or you need to think how system works in different scenarios. Okay, so in this video let us discuss the system design framework that you can use it while you are giving your system design now, right? So mainly you can divide system design round into a few steps. Let me write down the steps. So first step would be you need to get the functional requirements of the system. Okay, for example, maybe customer interviewer says design Uber for him. So Uber has many things as part of it, right? So it will have driver onboarding, then it would have rider onboarding, then it would have driver and rider matching service, then it would have one ride tracking service, then it would have many scenarios, right? So first of all, you need to understand what are you even designing. So in this in the first step of functional requirements, interviewer expects you to ask few questions and narrow down the problem, right? So you need to ask for scenarios that needs to be covered and narrow down the requirements. For example, matching rider to driver, is that the one, or tracking a ride and so on, right? So if you ask right questions and narrow down the requirements, right, interviewer will understand that okay, like you are able to understand the system even before jumping into designing something. That is one of the crucial parts while designing, to understand what you need to design and why you are designing. Okay, and also when you are whenever you are asking whenever you are narrowing down the requirements, it's better to explain the scenario. For example, you need not say should I do a matching service for rider to driver. Instead, you can say that okay, Uber designing Uber might be broader, it would have many multiple requirements, and given the time constraint, let me list down some of the requirements, and depending on the time we will design the requirements. Maybe I'm thinking riders and drivers are already on board in the system, and drivers are ready to take a ride, and whenever a rider wants to take a ride from a location, he should be able to see the drivers, and system should assign a driver to him. So elaborately discussing the requirement including the scenario clarifies most of the doubts, and also you will get a clarity on what you are designing for. So it's not a binary question saying okay, I'm doing matching service. Instead, it should be a scenario, like what are you assuming? You are assuming rider and driver already there. You are doing a matching service whenever you have a driver and also the location and so on. This way, you will understand the requirements, and then now that is the first step, right? So in that first step, you can spend some 4 minutes or 3 to 4 minutes, okay? Because a typical system design round consists of only 45 minutes or 1 hour, depending on the time and the company and the role that you have played for. So you need to design a system within 45 minutes. Okay, if you plan for 45 minutes, it depends on how fast you can, how fast or slow, and it also depends on the questions asked by the interviewer. So maybe you can spend 3 to 4 minutes on the first question, because first step is actually very important, that decides the entire system that you are designing for. After getting the functional requirements, you need to get the non-functional requirements of the system. So now again, you need to ask right questions, like uh, you need to ask you need to ask the non-functional requirements, something like so here you can have some questions, like first you ask about scalable system. So whenever you think of scalable, entire system may not be scalable, okay? So some parts of the system can be highly like um, scalability should be one of the important reasons, but you you should also justify it. For example, we are let us say we are designing some payment system only for India, or not only India, only for some part of the country where the number of users are fixed. Okay, because the number of users are fixed and you already know that the scale of the system is very low, if you say that okay, I will design a system such that it is scalable, it will not sound good, right? So whenever you say scalable, you need to say why. For example, when let us come to the same Uber question. Whenever he says design a Uber matching service, you need to say that we can say that let us say there are a number of people who are asking for a ride, and we have drivers to match them. So we need to design a system in such a way that if the number of users who are asking for a ride increases, system should be resilient for that. So that's why I need to design a system which should scale even if the number of people who are asking for a ride increase. So that's when he will understand, okay, he's just not blindly saying the system should be scalable, he also gives a reason why it should be scalable. So whenever you ask for scalability, you say why. Why should it be scalable? Because if the system is not scalable and more people are asking for a ride, and you delay the matching service, obviously the user experience would degrade. So think of user experience whenever you are designing a system, because users are the one who are using the system, and if you don't make it scalable, user experience will be hurt. So when you think from users perspective, interviewer will also be impressed that okay, we are designing the system for the users, and you are also obsessed with users experience. You can also ask about what maybe so availability, like definitely all the systems should be available. So that is availability is anyways most of the times it is should be high available only. It depends on the system. If at all we are doing some payments gateway payment system where availability is not a concern but consistency is a concern, that's when you need to ask about availability and consistency, right? So whenever you say availability and consistency, you need to say what parts of the system should be available, what parts of the system should be consistent. For example, you say payments, it should be highly consistent, although availability, even if it takes it. But if there is a Facebook post or a Twitter tweet, and whether how long does it take to reach a friend, it can be eventually consistent. So whenever you say system is available, system is consistent, you need to come up with scenarios. What do you mean by consistency? For example, as I said, when I tweet something, even if it takes some time to reach your customer, to reach my friend, it's fine for me because the number of people who are tweeting might be enormous. And even if it take 2 3 seconds to reach a friend, that should be fine. Like he doesn't even know that I tweeted 2 seconds early. It took 2 seconds. So that's why whenever you say I will do highly consistent, I will do eventual consistent, you need to see what parts, what scenarios are affected by this consistency and how is customer experience getting affected. So as I said, if tweet reaches late, customer experience is not affected. And take the payment way. If at all payment service is highly available, but it is not consistent, that's not what customer wants. Customer is okay with 20 seconds delay or something. 20 seconds, maybe if at all 10 seconds or 5 seconds, even if it takes time, it should be consistent. So it depends on the system what you are designing, and you need to come up with these questions of non-functional requirements like how scalable is the system. Whenever you talk about scale, you can talk about the scenarios, availability, consistency. Also, you need to talk about the scenarios, and then you need to maybe like scalable, availability, consistency, or three standard non-functional requirements. Maybe you can think of. You can also think about some of the other things like latency and response time. For example, you are designing a rate limiter, right? In rate limiter, scalability, availability, consistency are one of are some of the non-functional requirements. Response time is also very important because rate limiter is kept for all the APIs. So if the rate limiter service is taking time, obviously all the APIs would be delayed. So it depends on the system. What kind of questions are you asking? What kind of scenarios that you are saying? Whenever you say response time, you say that okay, rate limiter is the service which all the APIs will go through. So if at all I may take more response time give a response while rate limiting a request, all the requests will be delayed. So response time is one of the key non-functional requirement for rate limiting. So you need to see some of the other non-functional requirements as well, and you can talk about discuss some peak load scenarios. So you can also say we need to take care of the system when there is a peak load. For example, let us take Uber matching service only. Whenever 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 it is a weekend or some live concert is completed, many people come out of the concert and they try to book the cab Uber, right? So there is a huge number of people who are asking for a ride at some particular places, right, in some particular times. So how do you take that case into the system? So all these cases of non-functional requirements will let interviewer know that how critically you are thinking about the system, and how is the design changing based on these requirements. So 3 to 4 minutes for functional requirement, 3 to 4 minutes for non-functional requirements of the system. I would say it's better to spend 4 to 5 minutes on the entire requirements of the system because they will guide us the remaining process of the design, right? So now we have got the requirements. Then third step would be APIs. APIs of the system. So let us say we need to design writer matching service or over only. Okay. Don't think of REST APIs or what is the stack that you are using, like JSON, protobufs, XML. What is the kind of request response? You don't need to go through that in the system design unless interviewer wants you to. For example, your question is only about REST APIs. You obviously need to spend time on how you design APIs. If the question is about designing a matching service, interviewer is not interested on how well you know about API design. APIs can be implemented in multiple ways. They can be REST. They can even in REST you can use protobufs, XML, or anything. Like there are many n number of ways. There can be RPCs instead of REST APIs. There can be n number of ways, right? So instead of defining in REST or RPCs, you design it as a method. For example, for rider matching service, find driver, maybe write something like this location, okay, location, source, destination location, and then it gives a task UID on which you pull. So now in API design, you are saying that whenever a rider wants to find a ride, you back front end will fire this API called find driver. It provides information like who is the rider, who is the source what is the source location, destination location, and then in response you are saying you will give a task UID on which the front end can pull, right? So by this, we did not we are saving so much time on how you are actually giving request response, and you are you are you are telling what is the kind of APIs that front end can use. Then maybe one more thing like okay, so obviously driver will keep moving from place to place, right? So whenever a driver moves, or for every 5 seconds, maybe front end of the driver application can use an API for update location for a particular driver and location. This second API helps us to understand what is the driver's location at a particular time, and that will be used in find driver, right? Now we have discussed about APIs of the system, right? APIs are very important to understand what APIs should be scaled and what APIs need not, right? For example, update location. Update location update location API will be called by all drivers every 5 seconds, right? So you will understand now that while for handling update location, I would need system which can which can uh, which can handle this throughput. For example, let us say there are 1 lakh drivers online at a time online, then it would be 1 lakh queries per 5 seconds, right? So you can come up with a QPS for this. 1 lakh is 10 power 5. 10 power 5 by 5 would be 110 power 5 divided by 5 equal to 20k QPS. 20k QPS, okay? So you know that, okay, for a ballpark of what is the QPS per second API, you came up with 20k QPS. Now you need to design the system which can handle this QPS, right? Similarly, you can calculate the QPS for find the driver. Let us say there are 1 lakh is 1 lakh drivers, might be very less actually, but these are just ballparks. You can ask the interviewer about what is the exact numbers that we need to calculate the scale. Maybe 1 lakh riders, maybe one lakh there, then point 0.1, then it would be 100k, 10k, 10k riders asking for the fine driver. Then maybe 10k, I don't know, this is just a ballpark. Maybe you can uh, ask the interviewer for exact things. So let us say 10k drivers are asking for fine driver. You know that 10k QPS is for fine driver. That's also pretty too much, like pretty big QPS that system can handle. So now, while once you have come up with APIs, you know what are the APIs that needs to be that has high QPS, low QPS, and depending on that, you will understand how to design APIs, like how to design the system, right? For example, now 20K QPS cannot be handled by a single server, so you know that okay, different drivers will be redirected to different nodes, and they will have locations for drivers on a distributed database, which will which will be updated every 5 seconds. Now, every even for database, now you need to understand that if at all.
So once you have the API and the QPS, you will understand that how a backend system can be designed to handle this QPS, right? So maybe now, if at all we are getting 20K QPS for updating location, we can definitely say that single server cannot handle this QPS. And even whenever we are putting this location into a database, a single database cannot handle 10K QPS. So you need to use a distributed database or shard the database, and then different drivers can go to different shards of the database and put it there. So these APIs and their scale tells us how to design the system. Okay, so now we have the APIs. You need to now go to high level diagram of the system. Okay, so you need to come up with different components of the system, and then each service can have its own database. Right? For example, I will let us see what can we do for designing Uber matching service. So we can say something like I'll keep a client, maybe I will say riders, then definitely all the riders cannot go to the same backend server, so I will keep a load balancer. Then there should be a location service which handles second API for updating a location from a driver, and then we should definitely again have a driver. Via this load balancer, we have a matching service, right? So now riders, what they can do is riders, they will go to talk to matching service by load balancer, and then they will get a driver. Drivers, they can talk, they will talk to location service to update their location. Now location service keeps all the data, all the location data of the rider in a DB, and then matching service talks to the DB and then gets all the riders within the approximate location for a rider, and then decides what are the required drivers, and chooses a driver and gives it back for a particular ride. So this now matching service need not have a particular database. It uses the location DB. Now this is just a high level diagram of what are the different components and how are they interacting with each other, right? Obviously, this is a very crude level of matching service. Like either whenever it calls matching service, matching might take so much time. So until that time, maybe uh, like matching can take 1 minute or 2 minutes. Right? Until that time, the instance which is managing a ride need not wait for it, right? Instead, what we can do is we can keep a Kafka queue where matching service instance put a request to queue, and then depending on different events while the ride needs to be updated, matching service instance picks up the ride. For example, in queue we can have different queues, right? Like uh, like waiting. Okay, so maybe there is a ride construct, something like we should also have a ride service. So for a particular ride, this manages the ride construct, and then we will have a DB ride service updates the ride entity into that one its own DB. Now in queue, what if I put ride event something like I will put ride ID actually, okay? Matching service, whenever it gets the request from rider that it needs a driver, it will just create a ride entity in this CDB and then put it here. Now, whenever some matching service instance is free, it will pick that ride ID and then it fetches all the drivers in that particular location, and then it uh, finds a particular driver for that ride, and then sends a uh, sends a request to driver to accept the ride, right? Right. So now, uh, depending on the size of the queue, we can scale these matching service instances, right? If the queue is increasing, it means that matching service instance need to be increased, and they can handle more, right? If the queue is less, we can decrease this matching service instance. So that way, queue is actually handling the rides which needs to be which needs to be matched yet, right? Now, so there should also be there is a location service, right? Matching service talks to location service to get a particular node to which the driver is connected and sends a notification to accept a ride. Once the ride is accepted by driver, it talks to matching service talks to ride service to update the ride as matched and start the ride, something like that. Okay. So so I have kept a queue now in this design. If you think about it, I have kept a queue prematurely, right? Uh, Now, if I think about it, a queue seems redundant. For example, what if the queue is not there? Matching service instance, which got the ride, it can create a ride entity, and it can directly talk to location service, get the matching drivers, and get the particular driver, right? So no need of a queue. So So whenever you are doing high level diagram or a system design, don't add components just because you know them. For example, I added Kafka queue because I know about queues, but don't make this mistake and only add the components which are required. And whenever you're adding components, you should also reason why they are needed. For example, I kept two separate DBs. Why did I keep two separate DBs for two different services? Because in microservice architecture, every service should have its own database. That's how it can be. We can remove dependencies and coupling. If at all everyone uses the same DB, now we are kind of creating a coupling between these two services, right? Instead, they can have their own DB, and let us say location service. If you think about it, the scale of the location service DB can be different from scale of the ride service DB, right? So scale of the location service DB depends on the number of drivers who are active. Scale of the ride service DB depends on the total number of rides. So scale itself is different. If each service maintains its own DB, it can be maintainable and individually scalable. So that's why whenever you are adding components, you need to think why they are needed and then add it. So as part of high level diagram, you have come up with the components and how they are interacting. So for the first step, we took 3 to 4 minutes here. Second step took 3 to 4 minutes. API also you need to complete by 3 to 4 minutes. High level diagram takes some time, so maybe 7 to 8 minutes. Okay, high level diagram. In this high level diagram, if interviewer asks some questions, it will take more time, but you can come up with some root diagram of how a happy path at least works, right? Here, you did not even go into database schema, how the different constructs are implemented in a DB, like what is the location service DB looks like, what is the actual DB that you are using here. All those questions can come in fifth step. Okay. So until now, our 4 steps are done. DB. So fifth step of the system design is database schema DB. So in high level diagram, you have come up with DBs, right? You need to now talk about what is the kind of schema that you use on DBs. For example, location service. For location service, for location data, you definitely need a driver ID and then latitude, longitude, something like that. Okay. So this is distinguishing columns. Okay. This mark. Now, if you think about it, I am not designing keeping MySQL as in mind or keeping NoSQL DB as in mind. Whenever you need to think of database schema, you need not think about DB. You need to think of what is actual data that you are storing. So for a particular driver ID, you are storing latitude and longitude, latest whatever is the available latitude longitude for that driver, right? Now, this latitude longitude should also have the timestamp when you got it, because if at all the driver was online 1 hour back and you are storing the driver ID after 1 hour also, it doesn't make sense because he might have already moved out of that location. So if you keep the timestamp, you can know whether the particular driver ID your location data is valid or not. Let us say we take some decision that only if the latest timestamp is within 20, say last 20 seconds, it is valid. So this helps us to find all the drivers in a particular latitude longitude near to it, right? Again, I kept latitude longitude, right? Instead, actually what happens is that we use some geohash for storing the data, and using geohash we can get the nearest neighbors, and that's a different topic on how we actually store it. But this video is about how to do data, how to do tackle system design interviews. So you have come up with database schema, and then you need to come up with all the tables in there. Now, once you have all the tables, you need to see whether something like you can come up with some ballpark storage requirements, saying now there were 1 lakh drivers, right? 10 power 5 drivers are there, and the QPS is also 10 power 10 20k QPS, right? This is what we did in step 3. Yeah, 20k QPS. Now, no database can handle 220k QPS. A typical database uses 250 to 500 QPS only. Okay, because the ATBs are disk disk operations. Okay, so now a simple database instance can give 250 to 500, but you need 20k QPS. So now here you have the requirement to shard the DB. When you have a requirement to shard the DB, now you need to you can discuss about DBs, right? So there are two kinds of DBs, right? Relational DB like SQL and NoSQL DB, right? So typically when you choose relational DBs is when you need asset properties, and when you need asset properties like atomic, consistency, isolation, durability. When you need asset properties and transactions, then you can think about using SQL. But if the system should be horizontal scalable and acid is not needed, and eventual consistency is fine. Okay, in these cases you can go with NoSQL DB. Now, if you if the requirements do not fall into these two considerations, what should you do? For example, we have a payment gateway where we have as a requirement, but because the payments are ever increasing, what will you do? So, so that's when you can that's when you can show your creativity, where you can say that asset properties are only needed if the payment is ongoing. Once the payment is cancelled or completed, you need not put it in SQL DB. You can put it in a NoSQL DB like Cassandra and then make it searchable, because once the payment is cancelled or completed, then it doesn't need any ASIC properties. It just needs to be stored for historical reasons, historical data, data bookkeeping. You just need to keep it. So basically, you need to come up with a way depending on the requirement, and then say that okay, like if you need ASIC properties, you need to make it. You need to use SQL, but with SQL it will become difficult to do horizontal scaling. So either you maintain multiple SQL service servers and then shard based on some ID, and then do some uh, do some like uh, scatter and gather algorithms to go to all the SQL servers and do something. But you need to you need to discuss what are the pros and cons. So, and one more key point while doing system design is the interviewer is not expecting a memorized answer or a correct answer. There is no correct answer in system design. It's all about trade-offs and approaches. And until now, we we have we from fifth step we will have all the trade-offs. So now we have different kinds of DB sets. You need to have different approaches. See, if I use SQL, these are the issues. These are the pros. If I use NoSQL DB, within NoSQL DB, we have different kinds of DBs like key value stores, like DynamoDB. Then we have document stores like Mongo. Then we have wide column-based stores like Cassandra. We have time series based stores like Influx. We have geohash based stores as well, provided by Google and Uber. So that's also fine if at all you know it. But there are some graph stores as well, which will be used by Facebook maybe. I don't know the exact Facebook DB name, but so there are multiple DBs. So you need to come up with what are the advantages and disadvantages of choosing a DB. For example, if you choose Mongo favors consistency over availability. So for system design, you need to read different architectures of databases. For example, in Mongo, if at all there are 50 nodes in the DB, there is a Mongo is a master slave architecture. So if master goes down, there is the right operations will not work for some time until a new master is elected. So there is uh, consistency with Mongo, but availability can take it. On the other hand, Cassandra. Cassandra favors availability over consistency, right? So here in Cassandra, it's not master slave. Any node can take updates and it can do the update. So there is no master and there is no downtime. So maybe if all the nodes are in Cassandra person, obviously there is a downtime. But there should be a factor of nodes which who's going down, the system can tolerate, right? So you need to understand what are the pros and cons with different DB, and then give your approaches. For example, in SQL, it's not vertically scalable. Okay, so in DBs, that's one approach where we can discuss different trade-offs and how you shard. Like again, we said about sharding, right? Here also we can talk about sharding, how you even shard. Like if you use driver ID, if at all the drivers go to one location. Like what if we shard based on driver ID in the location service, right? What if all the drivers in a particular shard are active, right? Again, that shard will become hotspot. So how do you shard? Maybe uh, we need to see hotspots and go and reshuffle the drivers to different shards, or if at all a particular shard is getting too many traffic, you need to move some of the drivers to other shards. So you need to come up with sharding trade-offs as well, trade-offs of sharding and all, sharding as well. Okay, so database and DBs are one of the important concepts because Generally, servers are designed in a stateless way. Your database at the end of the day decides how user experience is. For example, use NoSQL DB for tweets. It means that it's eventually consistent, right? So tweets will reach users with the eventual consistency, which is discussed in point number 2. So if you go with this flow, then you will understand how to handle different workflow scenarios that we have already discussed in the first number 1 and 2, and how to incorporate them in the design. And again, most importantly, interviewer is not looking for a perfect answer. Interviewer is looking for your thinking capability and the way you come up with different approaches and their trade-offs, and then map it to user experience, and then finally take a call, right? Now you have already come up with database schema. Now you need to ask interviewer on areas to focus, right? For example, you said, how do you handle peak loads, right? How do you handle peak loads in Uber rider service, matching service, right? So then you can come up with different approaches like uh, discuss about now. Let us say you are designing a LinkedIn where you need to uh, where you need to find the number of connections between two users. For example, user one and user two is there on LinkedIn, and you need to know how user one is connected to user two, whether it is a first connection or second connection or third connection. So we are kind of doing a BFS from user one to find user two. Now you need to think about if user one has too many friends, BFS will take more time. So you need to understand where system can break and come up with scenarios and discuss them. So sixth point is actually interviewer and interviewee deployment. So you need to, if you come up with some scenarios and say, I want to discuss this scenario, I want to discuss so and so scenario to understand how my system works and how I can change how I can change the system. So this way, your interviewer will understand that you can actually find the bottlenecks and trade-offs and issues in the current system, and you are also thinking of fixing them. And if at all interviewer has something in mind to discuss or some component to go deep into, he will tell them. So, so finally, system design is about, maybe I will write in Excel maybe. So it's about trade-offs. Okay, it's about trade-off, and you need to read the room. Okay, read the room in the sense, you need to understand what is the interview looking for. If at all you are spending more time on load balancer and your interview is actually expecting you uh, to go deep into matching service, it doesn't make sense, right? If you concentrate on load balancer, so you need to understand. It's all about discussing trade-offs, reading the room, and discuss. Discuss. Yeah, I think uh, these are the two things, and no single approach. Okay, don't use at any point in the discussion. Don't say I will go with this. Okay, say I'm thinking of these two three approaches, and then based on the pros and cons for this approach, I'm heading towards using approach 3, approach 1, and so on. Don't say I will use Cassandra. Why do you want to use Cassandra? That's what you need to explain. Tell why don't you want to use NoSQL. Tell why do you want to use Kafka. Why don't you want to use Kafka? So if you're using Kafka, tell something like why do you want to keep a notification service? Why can't other service do it? And so everything is about trade-offs and discussion around how you take it. So so these are 6 steps. In most important thing is read the room and see how you want to change the design or drive the discussion. So if you're not confident about some topic like geohash or anything, you need not you so uh, you can try not to drive the discussion there. Instead, think of approaches about different things in the database, different things in the system, and then talk about them. Yeah. So these three golden rules will, I think, these three golden rules and 6 steps will help you in system design round. Hope you like the video. Thank you.